Okay, here we are on day 44 of our HiSET test prep. And day 43, in math, we were looking at volumes of three-dimensional shapes. We did the volume of prisms, the volume of cylinders, and the volume of spheres. Today, they're going to continue with volumes of two more three-dimensional shapes, pyramids and cones. Pyramids and cones both come to a single point at the top. Anyway, we'll get to that, but first we're going to do our math windows. So if you turn to page 7 of 12 on day 44. And the first one, we have a bunch of variables, polynomial with variables, three different variables, and we have to simplify the expression. So we have negative 7w to the 7th times x to the 6th times y squared times w to the negative 7th times x to the negative 10th. And that whole thing is then to the negative 1st. Okay, so we're going to combine the w's, we're going to combine the x's, and there's only one y, so that's going to stay, right? Okay, now the thing to remember is, what do you do when you have a variable with an exponent multiplied times the same variable with a different exponent? Because we can group the w's together. Well, what do you do? Well, let's take an example. Suppose you have x squared times x cubed, right? Well, that x squared is 2x's multiplied together. And this x cubed is 3x's multiplied together. And when you multiply this times this whole thing is multiplied times that whole thing, right? How many x's multiplied together? 1, 2, 3, 4, 5. That's equal to x to the 5th. So there is a very simple rule here. When you have something like x to the squared times x to the 3rd, you simply add the exponents. It's not x to the 6th. You don't multiply the exponents. You add them. X squared times x third is x to the 5th. So that's what we're going to be doing here. We're going to be adding these two. So we have negative 7w to the 7th times w to the negative 7th. So what was my rule? You add the exponents. Even when one of them is negative here, you're going to add the exponents. Okay, 7 and negative 7 is 0. So you end up with negative 7 times w to the 0. And any number raised to the 0 power is equal to 1. That's a special rule for the exponent 0. When you raise anything to the 0, it doesn't matter what it is, it's 1. So this is equal to just negative 7. Another way of thinking of it is w to the 7th. An exponent to the negative 7th means it's underneath, it's divided by this. W to the 7th. So if it's a negative one, you just put it on the bottom and change it to positive. W to the 7th over w to the 7th, that's equal to 1. You can see that it's the same. Okay, anyway, we have our w. So let's do our x. So our w, the w's basically cancel. You end up with negative 7. Now x's, we have what? X to the 6th. This is all going to be times x to the 6th times x to the negative 10th. And there's also y left here. Y squared. Right? Okay, this was x to the 6th, not negative 6. It was positive 6. So you got 6 and negative 10. What's our rule? We add the exponents. 6 plus negative 10 is the same as 6 minus 10. 10 minus 6 is 4, so 6 minus 10 is negative 4. So this becomes negative 7 x to the negative 4th times y squared. But then it says, take all of this and take it to the negative 1st. So maybe the answer will appear as this on your multiple choice, but there are other ways that this might be written. So when you have a negative exponent, what you do is you put it on the bottom. So this could be written as everything on the bottom here. Written on the bottom like that, right? That's one way you could do it, right? So that could be an answer, but maybe the answer isn't going to appear that way. Maybe we have to do something with this -1. Okay, so now we want to think, what do you do when you have an exponent raised to another exponent? Okay, let me see what I can write that. I'll write that on here. So you have an exponent raised to another exponent. So let's say you have x to the squared again raised to the third power. That means you've got x squared times itself, x squared, and again times x squared. You got 3 of them multiplied together, 3x squared. That's 2, and remember you add the exponents, 2, 4, 6. That's equal to x to the 6th. So when you have an exponent and then you raise that to another exponent, that's when you multiply the exponents. Okay, that's different from x squared times x to the third. This is x squared raised to the third power. It's 3x squared multiplied together, so it's x to the 6th. So you have to multiply the exponents when you do this. So going back to our problem, so it could be written as -1/7 x to the 4th y squared. You might, x to the 4th y to the -2nd. So you might see it written as that. Or they might put these on the bottom because it's a negative exponent, and that's 1/7. So it might be written as negative x to the 4th. We'll leave the negative on the top. 7 y squared, because when it's a -2, it's the same as y squared on the bottom. So this might be how it might appear this way, or even that way. Those are all 3 possible ways it might appear. Okay, going on to number 2. Mean, median, mode. You know what we do? We'll skip the mean, we'll do the median, we put them in their order. 12, 15, 16, 18, 21, 26, 26. And we take the middle one. Well, there's 7, so that means 3 smaller, 3 bigger. The middle one's 18. When there's an odd number of entries, you take the middle one. When if there were an even number, then you have to take the middle 2 and get the average of those by adding them and dividing by 2. The mode is the most common one. Well, 26 happens twice, so that's there. The mean, how do you figure out the mean? The mean is the average. What do? You add them all up and divide by 1, 2, 3, 4, 5, 6, 7. You add them all up and you divide by 7. If you do that, I came up with, on the calculator, 19.14. Okay? Okay, number 3. Let's see where we are here. 3x minus 3 times 4x plus 1. What do? I multiply this first. We're going to take the first term and multiply it times this, and then multiply it times that. Okay, 3x times 4x is 12x squared. 3x times 1 is plus 3x. Now you take the second term. Minus 3 times 4x is minus 12x. And then finally the second term times the second term over here. Minus 3 times plus 1 is minus 3. Are we done? No, we got an x squared and we got a 3, but we got 2 terms that have x, so we can combine them. 12x squared plus 3x minus 12x. It's like 3 minus 12. 3 minus 12 is the opposite of 12 minus 3. 12 minus 3 is 9. 3 minus 12 is minus 9. X minus 3. Okay? Last one. Looks like a big expression. Solve the following expression using x equals 5. Well, all you got to do is put the 5 in wherever you see an x. So you got 4 plus 9 times 5. 45. You can use your calculator. 5x squared. What's x squared? It's 5 times 5. 5 times 5 is 25. Times of 5 is 5 quarters. It's $1.25, 125. Minus 3x cubed. We just did x cubed because we did x times x. We did 5 times 5 times 5. So that's the same as this. 5 times 5 is 25 times 5 is 125. But now you want 325. 3 times 125 is 375. And it's minus. Well, you ran those in your calculator. Now you run the total in your calculator. And what do you get? Minus 201. Anyway, that's what I got. Minus 201. Okay, so now we go on to the lesson. The lesson this week is volume, but of pyramids and cones. Okay? Let's see what they're calling a pyramid. So first of all, they're showing you what they're calling a pyramid. This is actually a pyramid with a four-sided base, a rectangular pyramid. Here it says a pyramid is a three-dimensional object with four triangles faces that connect to the same vertex. That's true if it's a rectangular pyramid, it'll have four triangles because there's four sides on the base. So this should really, that's the definition of this one, a rectangular pyramid. Okay, because if it has four triangles, that means the base has four sides. Okay, anyway, this is a pyramid with a rectangle for the base. Okay, and how do you find the volume? Well, you take the area of the base, the length, the width, the height, and you multiply, the length and the width, that's the area of the base, and you multiply it times the height. Now, if you do that, that'll give you the volume of the box that would be made with this base at the top and the bottom. But we don't want that whole box. We just want a point at the top making a pyramid. And so what do? Oddly enough, you multiply it times 1/3. I don't know how they figured that out, but that's what you do. Sorry. You take the area of the base, you multiply times the height. That would be the prism, the box. And then you take 1/3 of that to give you the volume of the pyramid. That 1/3 is the number you got to remember. Now, you won't even have to remember this. I'm sure they'll have this formula if they give up a volume problem with a pyramid. Okay? Again, what I like to do, instead of memorizing all these things, I just say the area of the base, because that's length times width. And then you multiply times the height, because you want to know how the height affects the volume. And then you take 1/3 of it. The cone is the same thing, really. It's the area of the circular base. A cone has a circular base and a single point. Notice that a pyramid has a rectangular base, this one does, and a single point. A cone is a circular base with a single point. Same thing. Take the area of the base, multiply it times the height, and then you take 1/3 again. There's the area of the base, pi r squared. Multiply times the height, and then you take 1/3. Okay? Anyway, read through this page so you understand how to compute the volumes of pyramids and cones, and then you can work on some practice problems. I'll go over 3 of them because it's really just the same thing over and over. Okay, this first one. So here's a pyramid. And there's the dimension. So you figure out the area of the base, which is 13 times 6. You multiply it times the height, times 14. And what that would give you the volume of the box, of the prism. You want the pyramid, so you do what? You take 1/3 times this. You can put this in the beginning. They like to put it at the beginning. 1/3. 1/3 means what? It means divide by 3. Multiplying by 1/3 is the same as if you had divided by 3. So instead of doing 1, because how do you do 1/3 in your calculator? You have to put 1 divided by 3. Instead of doing this, just put divide by 3 at the end. Anyway, you work that out on your calculator, you should get 364. What's the label? Cubic centimeters. Or you could also write it centimeters cubed, like that. 364. Number 2. Okay, what do you got? You got 21. Get the area of the base. 21 length times the width. Oh, it's a square, isn't it? 21 by 21. The height is 29. Again, that would give you the volume of the box. We don't want the box, we want the pyramid, so we divide by 3. You do that. I hope you're doing these now before I do them, because you should really know how to do them by now. Just follow the simple formula. 4,263 cubic meters, or you could put meters cubed. This one, what? Area of the base, 17 by 32 rectangle, times the height, 24. But then you got to divide by 3, because it's 1/3 the volume of the box. And what does that come out to be? Almost the same as the other one, 4,352. This time it's what? Cubic feet. Feet cubed. Anyway, I'm not going to do the rest of these, because all it is plugging those numbers into the formulas. Try them on your own. You don't have to if you're really confident you know how to do it, and you might even remember the formula. Then you can move on. The formula really makes sense. You take the area of the base, and you want to multiply times the height, because that affects the volume, how much it will hold. But because it's got a point at the top, it's not the whole base at the top, like a box, then you have to take it 1/3. How they got the number 1/3, though, I'm not sure at all. Okay, on to cones. Cones, we're going to be following the same formula. We're going to figure out the area of the base, and then multiply it times the height, and take 1/3. Okay, so how do we do the area of the base? It's the radius squared. 5 squared, that's 25. I could put 5 times 5. I'll put 5 times 5 on the first one. Radius squared times pi, 3.14. I'll put that in there. 3.14 times 5 times 5 times, that's times what? 12. And then in the end, what do you got to do? Divide by 3 again. And what does that equal? 314. Yeah, it's like pi. 314 cubic centimeters. Okay, volume of the cone in the middle. What are we going to do? Well, we're going to do pi times the radius squared. 3.14 times 14. Wait a second. Is that the radius? That's the diameter. We want the radius. What's the radius? Half of the diameter. 7 times 7 times 7. 7 times 7 is 49, but we'll just put it, right? Times the height, times 18, divided by 3. Now, if you know your multiplication facts really well, when you use your calculator, you're going to say 3.14 times 49, because you know that. And you know this too, divided by 6. It's simpler steps when you know your facts. But if you don't, just plug in the numbers. What does that one come out to be? 923.16. Okay, one more. An upside down cone. It doesn't matter, just upside down. So what do you got? You got pi 3.14 times the radius squared times 3 times 3. Oh, let's just put a 9. Times 7 But remember, that would give us the volume of the cylinder. We want 1/3 of that, so we divide by 3. And what does that come out to be? 65.94 cubic meters. Okay. Again, I'll leave the rest up to you if you want to work on those, depending on how much practice you think you need. Sometimes just doing repetitive problems over and over really helps the formulas sink in. Okay, on our word problem page, well, these are pretty much just what we just did, so I'm not going to do any of those. It's the same thing that we did on our last two. I'm on page 11 of 12, right? So I'm going to go down to the word problem, number 7. Okay. Advertisers have designed this pyramid-shaped package to hold action figures. So they built this package, and they made it 10 by 10 on the base. It's probably a square, right? 10 by 10 by 10 by 10. You can't see the other sides. And the height is 15 centimeters. After testing the design, the manufacturer decides to increase both the length and the width of the base by 4 centimeters. How many more cubic centimeters will the new package hold than the package shown above? I think the easiest one to do this is you want to know how many more centimeters does it hold, meaning what's the difference in the volumes. So you want to figure out the volume for this one and the volume for the new one. So the volume for the first one, let's call it A, is equal to what? The area of the base, 10 times 10, which is 100, but I'll write 10 times 10, times 15, the height, but then you have to divide by 3. Work that out. What does it come out to? 500? 500. If you know your multiplication facts, 15 divided by 3 is 5. 10 times 10 is 100. 5 times 100 is 500. Now, B, what did you do? At first, I added 4 to all these numbers, but it says you increase both the length and width, not the height. It didn't mention the height. So now it becomes 14 times 14. The length and the width we increased by 4, but we kept the same height. By 15 divided by 3 equals. Run that through your calculator. What do you get? 980. And then you subtract to see what the difference is. 480. There it is. A, the first one. Yeah, did I not show that properly? Oh, sorry. Anyway, there's our increased length and width. We increased from 10 to 14. The height stayed the same, and we divide by 3. We got 980, and we subtracted 500 and got 480. Okay, number 8. The height of a cone is half the diameter of its base. If the cone's height is 4, what is the cone's volume to the nearest cubic inch? Okay, it says the height of a cone is half the diameter of its base. Wait a second. If it's half the diameter, isn't the radius half the diameter? And that's what we want to know, the radius, to figure out the formula. So if the height is 4 and it's half the diameter, it's the same as the radius. That means the height is 4 and the radius is 4. How do we figure out the volume? We do pi, which is 3.14 we're using, times the radius squared. Well, the radius, we decided, is the same as the height. So the radius must be 4. 4 times 4 times the height, 4. And then what do we have to do? We have to divide by, we have to divide by 3. Divide by 3. And what do you get if you do all that? Well, multiply it out and see what you get. I ended up with 66.98, which is very close to 67. Right? Now, by the way, in cones, You're multiplying by pi and you're dividing by 3, and they're almost the same. So they almost cancel out. 3.14 is just a little bigger than 3. So your answer should be about 4 times 4 times 4, which is 64. Your answer should be a little bit bigger than 64. So that answer makes sense. It's a little bit bigger than 64. You could have almost done this without using your calculator, because you know that the radius is 4 and the height is 4, and the pi and the divide by 3 kind of cancel out. It's just a little bit bigger than 1. So answer's got to be a little bit bigger than 64. There's only one answer a little bit bigger than 64. Okay, number 9. Okay, it gives you two shapes, a prism and a pyramid. Which of the following is a true statement about the figures shown below? Now, our lesson is on volume, so you can guess it's going to be a volume question. So why don't we just figure out the volume before we start? Volume of a prism is just the length times the width times the height. 4 times 3 is 12 times 2 is 24. That one's easy. How about this one? The volume of the pyramid. Well, you take the area of the base, which is 3 times 3, that's 9. You multiply it times the height, and then you're going to divide by 3. Don't forget you have to divide by 3. Well, 6 divided by 3 is 2, and 2 times 9 is 18. You could put this in your calculator, it'd be 54 divided by 3, 18. So this one's 24, this one's 18. Now let's read. The volume of A equals the volume of B. Are they the same? No. Wrong answer. The volume of B is greater than the volume of A. The volume of B is greater than A? Nope. Wrong answer. Both A and B have a volume greater than 20 cubic meters. Yes. No, not greater than 20. Wrong answer. The volume of B is less than the volume of A. Yes, absolutely true. 18 is less than 24. Last one. A cone's base is a circle with a radius of 8 inches. The cone's height is 15 inches. What is the cone's approximate volume in cubic inches? Well, we're going to take the radius, square it, multiply times pi. That gives us the area of the base. Pi times the radius squared. Then we're going to multiply times the height and divide by the we're going to divide by 3, right, for the volume of the cone. Now, again, we're multiplying by pi and dividing by 3. They almost cancel. So you're really left with 8 times 8 times 15. What's 8 times 8 times 15? Well, 8 times 15 is 120 times 8. I think is 9. This is like 960. If you put that in your calculator. So the answer has to be a little bit bigger than 960. Which one's a little bit bigger than 960? That one, right? That's what I got. I hope I didn't make a mistake here. 8 times 8 times 15 is 120 times 8 is 960. Yeah, that looks right. 960, a little bigger than 960 would be 1,000. Okay? You can actually put this in your calculator, of course, and you would come up with some number that's close to 1,000. They said, what is the approximate? That's why I tried to do it by estimating instead of using my calculator. But even when they ask you for approximate, a calculator is fast now, so you can do that. In the old days, we had to do all this multiplication, so we liked doing approximations. It was faster, and it gave us around the right answer, which is important because often you don't need to know exact answers. You just have to know about how much something's going to cost, about how much you're going to need of something. You need an estimate. Those are called estimates. Anyway, that's our lesson 44. And there's only one more lesson, 45. And then we get to start all over again at lesson 1.